18 years ago, Elon Musk founded SpaceX to send a rocket to Mars, kickstart a second space race, make spaceflight cheaper, and inspire a new generation of scientists and engineers. Now, SpaceX is about to achieve those ambitious goals it set out to accomplish 18 years ago. SpaceX has been developing its Starship rocket since 2007 and is also focusing on the development of its Raptor rocket engine, the world's first full-flow staged combustion methane engine. This video is the second part of a series of videos exploring the Starship rocket's engineering aspects. We have discussed the Raptor engine's engineering side in our previous video, so check out that video before proceeding. Link in the description. Also, do not forget to subscribe to the channel for future videos in this series. This video focuses on the developmental history of the Raptor engine from 2009 to 2020. With NASA awarding a $1.6 billion contract to SpaceX in 2008, SpaceX's Mars project began to take shape. On 18 June 2009, at the American Institute of Aeronautics and Astronautics, SpaceX dropped its first hints of how it would get to Mars. Raptor, first presented in 2009, started as a low-priority project to develop a cryogenic upper stage engine, powered by liquid hydrogen and liquid oxygen. We also have begun initial design of the Raptor liquid oxygen hydrogen upper stage, which dramatically increases payload performance, said Max Vazov, senior mission manager for the company, during the 2009 Innovations in Orbit event.
And we are also have begun initial design of the Raptor LOX hydrogen upper stage, which dramatically increases payload performance.
SpaceX McGregor Rocket Development Facility Director Tom Markusik introduced the Raptor engine at the following year's conference, held on 30 July 2010. The Raptor engine, designed to power the upper stage of the company's Super Heavy rockets, was then planned as staged combustion hydrogen-fueled rocket engine. The earlier design of the Raptor was capable of producing a vacuum thrust of 667 kilonewtons and a specific impulse of 470 seconds. The first clue that SpaceX was seriously considering using staged combustion methane engines instead of hydrogen engines came in May 2011. SpaceX asked if the US Air Force was interested in a methane-fueled engine as an option to compete with the kerosene-fueled engine that had been requested in the reusable booster system high-thrust main engine solicitation. The next biggest hint of Raptor came in October of that year, when Musk described a new rocket called Mars Colonial Transporter, powered by an engine several times more potent than the Merlin. We have discussed the complete evolution of SpaceX Mars rockets, from Mars Colonial Transporter to Starship in our previous video. Link to the video is provided in the description. At the Royal Aeronautical Society in London, on 20 November 2012, Musk announced that liquid oxygen and methane would be SpaceX's main propellants of choice. He planned to use reusable rockets, along with Mars landing and ascent craft, to take humanity to Mars within 15 years.
Well, the cheapest fuel is methane. And also the nice thing about methane is that you can create it on Mars. Because Mars has a CO2 atmosphere, and there's a lot of water ice in the soil. And conceivably, I mean, you might be able to extract water vapor from the atmosphere, but that may be harder than simply mining water. But then with water you've got H2O, with a CO2 that gives you CH4 plus O2, and bingo, you can replenish propellant.
On October 23, 2013, SpaceX signed an agreement with the state of Mississippi to test the Raptor rocket at NASA's John C. Stennis Space Center. The first phase of tests at Mississippi started with the test of engine components, because the E2 stand at Stennis is not big enough to handle the whole Raptor. The problem was that the E2 stand was rated for 445 kilonewtons of thrust, but the Raptor could generate more than 2,900 kilonewtons. The tests focused on developing robust startup and shutdown procedures, which is quite challenging for full-flow staged combustion cycle engines. Initially, the Raptor was meant to use only on the upper stage of the Mars rocket. But on 2014, SpaceX confirmed that Raptor would be used both on the second stage and on the core stage of the Mars Colonial Transporter. SpaceX then completed the main injector testing in late 2014. Furthermore, in June 2015, SpaceX completed a full power test of Raptor's oxygen preburner component. The prototype Raptor reached SpaceX's McGregor rocket engine test facility in Texas in August 2016. The first test firing of Raptor was performed on 25 September of the same year. Next day, Musk revealed that their target performance for Raptor vacuum version was of specific impulse 382 seconds, with a 3 meganewton thrust and a chamber pressure of 300 bar. After 1 year of rigorous tests, in September 2017, a sub-scale Raptor test engine achieved a chamber pressure of 200 bars. The engine had undergone 42 main engine tests, with the most prolonged test duration being 100 seconds. After 2 years of test on the subscale versions, the Raptor engine's first flight version arrived in Texas in late January 2019. On 3 February 2019, SpaceX performed the first test of the flight version engine. The test lasted 2 seconds, with the engine operating at 60% of rated thrust, at a chamber pressure of 170 bars. On 10 February 2019, Musk announced on Twitter that the flight version engine had attained the chamber pressure of 268.9 bars. Later, a batch of Raptor engines from serial number 2 to 6 arrived at Texas Starship construction site. After several ground tests, serial number 6 was finally approved for the flight test. The first flight test of a Raptor engine occurred on 25 July 2019 at the SpaceX South Texas launch site, carrying SpaceX Starship prototype Starhopper to a height of 20 meters. On 27 August 2019, Raptor serial number 6 conducted another flight test at the Texas test site. The Raptor's 1-minute flight test took Starhopper to an altitude of 150 meters. After a series of tests for the next 1 year, on 19 June 2020, Musk announced that the Raptor engine achieved the expected chamber pressure of 300 bars on a test stand. 1 month later, on 4 August 2020, Raptor serial number 27 propelled Starship prototype serial number 5 to an altitude of 150 meters at the Texas test facility. The total flight time was approximately 50 seconds. On 18 August 2020, Musk announced that the Raptor engine reached 330 bar chamber pressure without exploding, setting a new world record of highest pressure ever reached in a rocket engine's combustion chamber. The engine beat the Soviet Union's RD-701 engine, which previously held the record for the highest combustion chamber pressure for an orbital-class rocket. SpaceX previously mentioned that the Starship Super Heavy will have 31 Raptor engines. But, during the Humans to Mars conference held on September 1, Musk stated that the Super Heavy booster might have only 28 Raptors on it.
We'll probably have, we might have fewer than 31 engines on the booster, because we're trying to simplify the configuration. So it might be 28 engines, which is still a lot of engines.
Out of which, the outer 20 engines will have around 300 tons of thrust. And the inner 8 will have 210 tons. So, roughly 7,500 tons total thrust at sea level, or a 1.5 thrust-to-weight ratio for Starship and Super Heavy combined. Also, the outer 20 booster engines will have no thrust vector control actuators, and steering control comes from center 8 actuators and differential throttle of outer engines. A successful test hop of Starship serial number 6 then took place on 3 September 2020. Raptor serial number 29 propelled the Starship prototype to an altitude of 150 meters. After a flight of approximately 50 seconds, Starship serial number 6 landed on the landing pad. On 5 September, SpaceX shared a photograph on Twitter showcasing the gigantic Raptor vacuum engine. Elon Musk gave a 50% chance of survival for this initial version in its first test. He also stated that the thrust is only slightly higher with the big bell nozzle version, and the larger bell is primarily for efficiency in vacuum. The Raptor vacuum engine aims for a specific impulse of around 380 seconds, while the initial design is projecting for a specific impulse of 372 seconds. Within less than 3 weeks after shipping to the Texas Rocket Development Facility, on 24 September 2020, the Raptor vacuum engine completed a full-duration test fire. SpaceX Raptor engine developments are still in progress, and we can expect further details in the next SpaceX Starship event, currently expected for October 2020. We will be covering the major announcements from that event in our future video. So, do not forget to subscribe to this channel to know more about SpaceX and Starship developments. And as always, thanks for watching.